Hello, my name is Patty Mantia, and I'm here today to speak with you about monitoring intensity of exercise. We know this is an important thing because we want to allow our clients to exercise at a level that induces a training effect, but not so hard that we put them at risk. Monitoring intensity can be done in many ways, the most accurate of which is measuring VO2, or volume of oxygen consumption. This is also, however, the more difficult because it requires more extensive equipment and more training. And most health clubs don't have that type of equipment. But because there is a linear relationship between heart rate and VO2, we can use heart rate to assess intensity. If you look at the graph on the right, if we were to plot our workloads and measure heart rate and measure VO2 and then connect those dots in the graph, we'd end up with a straight line or a linear relationship. So that means if we know heart rate, we can predict VO2, and if we know VO2, we can predict heart rate. We can also use the talk test, RPE, rating of perceived exertion, or Borg scale, or METs, metabolic equivalence. 1 MET is the energy cost at rest. That can be expressed in terms of kilocalories per kilogram of body weight per minute, or milliliters of oxygen per kilogram of body weight per minute. This will be discussed in a different video. Heart rates that we use in fitness include resting heart rate, maximal heart rate reserve, training heart rate range, and recovery heart rate. And notice there are abbreviations for each of these, and you would want to be familiar with these as you'll see them frequently. Resting heart rate is that taken first thing in the morning and averages between 60 and 100 beats per minute. We know that a fit heart will have a greater stroke volume, and given a workout, if the stroke volume increases, the heart rate will decrease. So what we can take from that is a lower resting heart rate is indicative of a higher stroke volume and ultimately a higher fitness level. There is, however, a genetic component to this as well. So it is possible to be fit and have a higher pulse and vice versa. Max heart rate is the highest rate the heart will go in a normal rhythm. It is not influenced by fitness, but is, however, influenced by age. 2 common formulas used to calculate the theoretical or age-predicted max heart rate include 220 minus age to estimate max, or 207 minus 70% of the age to estimate max. Each of these has a margin of error, so keep that in mind. Not all of your clients will fit neatly into this average package. Recovery heart rate is that taken at the end of the workout. We know that a fit heart will recover more quickly than a deconditioned heart. So if someone is able to recover quickly, it's likely that they're fit. If they cannot recover quickly, it may be that they've worked too hard and that they should work less intensely next time and include a longer recovery to avoid blood pooling. Heart rate reserve is the usable heart rate range. By usable, I mean you can't ever go over max, or you won't go under resting without being in some sort of cardiovascular event. So the range between maxing and resting is usable, or the heart rate reserve. Training heart rate range is the range needed to induce a training stimulus but not overexert. 2 formulas we use to calculate this are simple and the Carbonin formula. The simple formula is easy to do. You take a percentage of the max, and that's the intensity that they'd work at. And the range that we use for this formula is 64 to 94%. The great part about this is you can use it without knowing the resting heart rate. So you may have a client who can't remember to measure it, and so you could use the simple formula to give them a training heart rate range. The Carbonin formula is a little more complicated, but does give you a more accurate range because it takes into account the individual's resting heart rate or fitness level. But the downside is, of course, you do have to have that resting heart rate to use this formula. And this is not apples and apples. If you look at the images on the left, this is a glass of water, and notice if you pour the water in, it goes all the way to the bottom. This is a glass of water in a glass with a fake bottom. If you were to fill this glass with water and tell the person to drink half, they'd probably drink halfway down the glass, which would be half of the water. That would be similar to what we do with the simple formula. We calculate a percentage of the whole thing. With the Carbonin formula, this is the cup with our fake bottom. If you told someone to drink half, they might drink halfway down the glass, but that's less than half of the water. Half of the water would be up here somewhere. So in order to do this properly, you'd have to take this bottom away, calculate half, and then re-add the bottom. And that's exactly what you do when you do the Carbonin. You take the max, subtract out the resting, calculate 50% of that, or whatever percent you want to use. But it's 50% or a given percent of the heart rate reserve. So 50% using the Carbonin formula does not equal 50% using the simple formula. Which one is more accurate? That would be the Carbonin. Which one is easier? Obviously the simple. Again, the recommended range for simple is 64 to 94% of the max. So if I had a 20-year-old, the age predicted max would be 220 minus 20, or 200 beats per minute. You simply multiply that 200 by 64% to get the low end. You multiply 200 by 94% to get the high end of the training heart rate range. And so for this 20-year-old client, the training heart rate range would be between 128 and 188 beats per minute. Now, you're not going to give every client the entire range. You will have to narrow that down for them based on their age, health status, fitness level, duration, frequency of exercise, goals, motivation. That's where the art of exercise programming comes into play. The Carbonin formula is a little more complicated. You'll notice that in the parentheses we have to first take 220, subtract out our age to get the age predicted max, and then we need to subtract our resting pulse. This is the first step, what's in the parentheses. Then we'll multiply it by the percent, or do the part of the equation that is not separated by a symbol. And then the final step would be to re-add the resting pulse. So if you look at these carefully, these three formulas are saying the exact same thing. 220 minus age is the age predicted max. If you subtract out the resting, you have the heart rate reserve. So step 1 would be 220 minus age to predict the maximal heart rate. Step 2, max minus resting, to get the heart rate reserve. Step 3 would be to multiply the heart rate reserve by the low end of the training range, and in this case we'd use 50%. And the final step, or step 4, is re-add the resting heart rate to that number. And then you would repeat the same series using the high end, or the 85%, to get the whole range. And once again, remember, you'll need to narrow that down for your clients. Let's do an example. If we have a 20-year-old with a resting pulse of 60, and we know that because the client measured it and then reported to us, we're going to take 220 minus our age, which would give us 200. Then subtract out the resting. So 200 minus 60 equals 140. The next step would be to do what's not separated by a symbol. So 140 times 50% would equal 70. And the final step, re-add the resting pulse, or 60, to get 130 beats per minute, which would be the low end of the training heart rate range. For the high end, you do the same formula using 85%. So 220 minus age gives us 200, minus their resting of 60 would bring us to 140, times 85% is 119, and again the final step is add that 60 back, which would bring us to 179 beats per minute, or the high end of their training heart rate range. So for this client, the low end was 130, the high end is 179 beats per minute. So we may tell them somewhere between 130 and 179, or more likely we'll narrow that down to a smaller range for them. Remember that people who are deconditioned or are really only interested in health goals really might not want to work at a higher intensity. So it's okay if they work at, say, 60% using the simple formula. It's still going to give them health benefits. Or using the Carvonin formula, you may go as low as 40 or even 30% of the heart rate reserve. Anything is better than nothing. Even light workouts will give us health benefits. Here's a comparison of the simple, or percentage of the max, and the Carvonin, or percentage of the heart rate reserve, to show you this is not apples and apples. Simple Carvonin, all the way up to the end. Notice that there's not much difference at the high end of the training range, but at the low end it becomes much more important that we do get that resting pulse so that we can use the Carvonin and give them a more accurate training heart rate range. I mentioned the RPE or Borg scale. The original scale was designed to correlate with heart rate. So if your client said, well, I feel like I'm a 12, and then they measure their heart rate and they're at 160, they should have reported a 16. So we can tell them, actually, you're working much harder than you're identifying, and so you're really a 16 right now, and that helps them correlate what they're feeling with what they're doing. The newer version is the 1 to 10 scale, much like you'd see in the doctor's office. On a scale of 1 to 10, how bad is the pain? Well, when they're exercising, how hard are you working out? If they report a 9 or a 10, they need to slow it down. It should be somewhere between 5 and 7. And to the right of this, you see what's referred to as the dyspnea scale, which is a similar scale, but for people who are discussing breathing. So this might be used for asthmatics or people with emphysema or COPD. You might say on a scale of 1 to 10, how bad is your breathing today? If they say it's a 9, then you're probably not going to work out or certainly lighten that load to ensure their safety. So these are handy little tools for us. That is the end of this video. Hopefully you've enjoyed and learned something today, and I will meet you in another video. Thank you.